show you, which will be kind of fun. All right, thanks everyone for coming to my dissertation PhD candidate seminar. You guys all know me, I'm Mark, and I'm going to talk to you today about online design communities and how some of my work has sort of played into that through my dissertation. I want to start by a story about DARPA. So DARPA just recently had a challenge. Basically, does anybody know for a company like Ford, when they want to make a car, how long it takes them from the day they decide they want to make a new car to when they finally finish the full design of the car, how long that takes? Take a guess. How
3 years.
Okay, any other guesses?
5 years.
15. Okay, so it used to be more like 5 or 6. Now it's down to about 1.5 years. Any idea how that changes when you start looking at something like an armored vehicle design that's done by like Boeing and Lockheed and all of those? Do you think it's more or less? More, much more. In fact, often several, maybe even decades, multiple millions of dollars, and DARPA kind of got sick of this and said, okay, well, why don't we just put $1 million on the table and instead ask the internet to do it. Internet, you design us the next generation of armored vehicle design. And that's exactly what they did. They set about with these 3 competitions. They just finished the first one last April, and they put $1 million on the line. They had about 1,000 participants. Many of them didn't even know each other. They formed into about 200 ad hoc teams. It took them about 3 months to come up with not one, but about 5 different configurations that all satisfied the Marine Corps' requirements. So DARPA sort of viewed this as a key to, oh, well, these online design communities can actually do something that these other community, traditional companies like Lockheed Martin maybe can't do. If armored vehicles aren't your thing, then we can talk a little bit about IDEO. So I've done a lot of my dissertation research, which you'll hear about, is work that I've done with IDEO. They run an open source version of their site called OpenIDEO. And basically how this works is that volunteers come in and they have some big picture social challenge. For instance, how might we restore vibrancy in cities and regions facing economic decline? So an example that they use a lot in this challenge is Detroit, right? How can you sort of revitalize downtown Detroit, which has faced a lot of economic decline? And so they'll have thousands of participants come in, submit hundreds, sometimes thousands of ideas, and sort of all work to, and they'll end up selecting about 10 of these ideas that the sponsor of the challenge will push forward. One of the ones that came out of this was an architect by the name of Eric Cho. He works in the Lower East Side of Manhattan. He combined 3 or 4 of the winning ideas into something that he calls Made in the Lower East Side. Basically, he takes dilapidated storefronts and he has this 6-foot cube on wheels that you can wheel into a storefront, decompose it, and then you can create stages, you can create art galleries, you can create education spaces. And there's about 14 to 15 of these pop-up shops, he calls them, in the Lower East Side of Manhattan. Right now, you can go visit. So that's another example. And the last example I want to talk to you about is a guy named Garthan Leslie. He's a Columbia, Maryland resident. He used to work for the Department of Energy. And basically every day on his way to work, he would look at these in-window air conditioners, and basically they're just running all day. People leave them on in the morning, so that when they come home in the afternoon, their house is nice and cold, because it's quite warm in Maryland. And he said, well, isn't there a way that maybe it could sense, when I'm driving home, or I could activate it from my smartphone, and it could automatically turn on before I get there and save a lot of energy. So in November, he went on to Quirky. Quirky is another one of these online design communities. About 3,000 people helped him develop this idea for some smartphone-controlled in-window air conditioner. And then GE, who partnered with Quirky, used their patent portfolio to bring the resulting design to market, and it went on Amazon in April. So from November to April, this thing went from an idea in Garthan Leslie's head to something you can pre-order on Amazon. Okay. So the central question is, why do DARPA, IDEO, and GE, and all of these people use these online design communities? Why not just do it in-house? Right? In DARPA's case, that might be a cost issue. In OpenIDEO's case, it might be a reach issue. How do we get people into all of the dilapidated cities across the United States to get a reasonable sample? I'm not going to pay employees to go to each one of those cities. And in GE's case, maybe it was trying to leverage the expertise of the thousands of people that come onto their site. But this isn't, it's not so straightforward as just taking 2,000 people and sticking them into a chat room. Right? You're not going to get an air conditioner out just by having people just talk together. There needs to be some sort of structure there. And so essentially what my dissertation addresses is how do you take these online communities and help them effectively use the data that they generate, which is quite a lot of data, to help them manage their operations and improve their designs. Right? That's sort of the central question that my dissertation addresses. And usually at this point, I ask myself, okay, well, why is now the right time to be looking at this problem? Why don't we address this 10 years ago? Why don't we just wait 10 years to address it now? And basically, there's three factors. The first factor is what I call the democratization of design. This is the whole maker movement. The fact that everybody realizes you don't necessarily have to have a bachelor's of science in engineering to be a designer. And so a lot more people are wanting to get involved, and that's why you start to see a lot more impact and people willing to participate in these communities. The second is the growth of these crowdsourcing communities, things like Kickstarter, things like OpenID. A lot of these have only developed in the past 5 years. They haven't been around long enough for it to have been a viable field of study about 5 to 10 years ago. And the last is that now we have some big data and data science techniques that allow us to actually introspect on some of the data that these communities are generating. So this is sort of the three areas that are driving, the three big social trends that are driving the research. And what does society gain if we solve this problem? Well, right now, if you graduate from Berkeley, you basically have two options if you want to do product design. You can go work for a large firm like General Electric or IDEO, or you can get together with some of your buddies and create some kind of startup, right? Those are essentially your two options. And I feel like these communities represent a third option that can transform the way that we view the way that engineering work is done and taught. Right? Here you have people like Dr. Leslie, who's estimated to get about $1 or $2 million from his contributions to Quirky just for that air conditioner. He didn't have to be part of a large firm or a startup, right? But there are a lot of issues with these design communities that need to be overcome before we can do that. That's essentially what my dissertation tries to address. Okay, to do that, and I need to leverage three areas. First is design and engineering. Second is machine learning, and the third is crowdsourcing. So these are the three primary research areas that my dissertation sort of leverages. Okay, and I'm going to structure my dissertation, or the way I attack these problems, into three areas, or three hierarchically structured areas. First, at the community level. So how do you even make these communities work in the first place? How do I sort of herd the necessary number of cats in order to make the design even possible? Once I've even established that community, then we have to think about, okay, well, how do we structure a process, a design process that can take these thousands of people and have them produce an air conditioner on the way out? And then lastly, even within that process, there's the generation and evaluation of particular ideas. So I'm going to talk to you a little bit about work that I've done in each one of these three areas, just to give you a flavor of what that involves. Okay, so at the community level, I'm going to talk to you about work I've done with IDEO. This is their open IDEO platform, so I have some collaborators there that I've been working with for the past year and a half. And just to give you an idea of open IDEO, again, they have these sort of big picture social challenges. You saw the one about economic decline. There's things about healthy workplace communities, maintaining well-being as people get older. These are kind of the big picture social questions that they address and the types of challenges that people participate in. Okay? And what's interesting about them is when you can start to look at the social structure, how do people communicate, and compare that to things like Facebook or research co-authorship. And so one of the things you can do is look at the interactions between individuals. So this is actually one of the challenges. I forget which one, I think challenge 5. And it's basically each one of these dots is a person, and each one of these edges is communication between them. So this is sort of your standard social network analysis type graph where you're looking at collaborations between people. So you have sort of loners out to the end here, which sort of don't communicate and collaborate with anybody, and then the people in the center who are very highly connected, right? And this is looks very similar to Facebook and all those, except for one key property. And the one key property is something called disassortativity. That's basically a fancy word for saying that the people who collaborate the most collaborate with people who don't collaborate with other people. In other words, so the most gregarious folks are collaborating with the people here on the periphery. This is not the case in Facebook. Right there, the sort of the chattiest people are always with the chattiest people, and the loners are kind of out by themselves. And this has a couple of interesting properties. The first is something called robustness. So I'm just going to go ahead and just sort of break apart this network just so you guys can get a sense of what it looks like. You can sort of see how densely connected it is, right? And there's a lot of people, like even if I try and move them out, it's not like a bunch of people kind of follow this person out. There's sort of a lot of dense connections that exist in this network. And this has two kind of key properties. The first is robustness. If this person here decides to leave, all of a sudden I don't have all of their connections with them, right? That's good because people here are basically volunteering their time. They can't just, I'm not paying them necessarily to work in this community. The second is something called efficiency. So if this person has an idea and wants to communicate that idea to a lot of people, what we want is for that information to propagate very quickly to everyone else in the network, right? Having this kind of structure allows for exactly that because it can quickly hop between multiple people in this network. It also has very low clustering. In other words, there's not 5 people who are all talking together, right? it's very widely distributed. So this is a really interesting social network property that is not observed in any other kind of any kind of social network that really gives IDEO some really interesting properties. Okay, then we can start thinking about, wait, well, what are people actually doing in these networks? How are they communicating with one another? And so on this, we see here's time from when the network, from when OpenIDEO first started till November of last year when I finished collecting the data. And each y-axis here is a particular person. So I can look at particular activities. So for instance, here's when people joined. You can see a line when everybody's sort of been joining over time. You can see when people submit concepts. So basically when the challenge starts between when it ends, you can sort of see blocks of time there. And also the same with commenting, which kind of happens throughout. But what's most interesting is when you go ahead and normalize things by when people actually start. So in this case, I'm just going to move everybody over to the left. And this is the number of days, basically, since they started joining the network. What we see now is that basically there's a huge cluster of activity basically right around the first challenge. After the first challenge, there's this huge drop-off, except for when challenges are overlapping. Then you start to see people kind of continually involved in the network. So you can sort of see that there's sort of there's some people, like this person here is Mina, who are basically just constantly collaborating with everyone. They represent a very small minority of the participants, maybe only about 7%. Then you have people that sort of participate a couple of times in a few challenges, and then there are some people who are just sort of one-offs. They do one thing and they never come back. And so that's how people are using the network there. Okay, so those that are at the design community level. Now let's talk a little bit about design processes. So how do you sort of shepherd people together into one particular process? And in this, I'm also working with IDEO, but it's a separate site called HCD Connect. What HCD Connect does is it's basically a way for designers to share stories, what I call case studies, about design problems that they faced and what methods they used to overcome that problem. So IDEO has a set of 39 methods, and basically they have little case studies. Here's one where somebody went to a village in Uttar Pradesh in India during a disaster relief thing and looked at how the community sort of responded to it. So they write up a little story with some pictures and about a couple pages of text, maybe there's some video in there. And then there's a series of methods they can sort of tag which of the 39 methods were used and then what kind of problem area this was. Whether it was an agriculture problem, was it a healthcare problem, et cetera. And so the idea is that a designer can come in who doesn't know anything about design. They can read through the case studies. They, oh, I see. That's when I want to do some kind of interview process. Or that's the kind of thing I want to use for an agriculture problem. The issue, of course, is that there are hundreds of these, thousands of these. So no one's actually going to sit through and read all of these case studies. So the whole purpose, basically, of having this platform here, which is to disseminate knowledge in cases, you basically can't operationalize that because there's just too much information there for them to deal with. So some questions that novice designers would typically have would be things like, oh, well, which methods work together? Like, if I'm going to do one, do I need to do another one, or should I not do a different method? There's certain types of methods work better for certain types of problems. If you're going to do an agriculture problem, is there one method that's like the go-to one for that? And I'm not going to discover it unless I dig through all of the agriculture case studies. And then lastly, if I had actually gone through and read all those case studies, could I make more informed decisions about which design methods to use on a new problem? Right? Can you recommend for me which kind of methods I should use for what type of problems? So I'm going to talk about some ways that machine learning and data science techniques can play into these. So, for example, which methods work well together? You'll notice on the side here that even if I hadn't read any of this information regarding this, it actually tells me sort of which methods were used for this particular case. If I take all of those and I build up if I look at just how they vary together with what I call a covariance, or how they correlate with each other, you end up with this matrix, right? So here are the 39 methods, and sort of it's dark blue if they're highly covariant, and white if there's no covariance. Nothing was negatively correlated, so there wasn't anything that like substituted. If I did this one method, then I never did something else. Nothing was like that. It was either zero or positively correlated. And so you'll see things like, where is one here? So like individual interviews and group interviews. That makes sense. They're both interviewing types of processes. That would make sense that those two would go together. And so this is kind of useful in and of itself. But what's more interesting is when you start to look at actually the structure of this matrix and what that can tell you about the method. So for example, I can do something like spectral clustering, where I embed this. I take the sort of eigendecomposition of the matrix and resort the methods, and now what you see is that actually sort of blocks of methods start to occur. That's something that you would not normally have seen if you were just looking at the matrix itself. By taking its eigendecomposition, I can see what that is. I can actually start to see what that is, and you can do things like have an algorithm cut this graph up into 3 different blocks, for example. And the reason I picked 3 here is that it turns out that IDEO has already segmented their methods into 3 categories. Do you want to get what those 3 categories are? They're identical to the things that you could pick up via spectral clustering on this covariance matrix. So just by looking at how people are using it, even if I had no idea what these methods are or how they were related, I can uncover that design process, what they were doing, just by using the properties of this covariance matrix. Right? This is, I didn't have to know anything about what an interview was or what a framework was.
We've been back and forth with whether IDEO.org is going to be a cooperative. Sean,
we sent him the paper.
We saw the paper, but I don't understand it.
I don't know. He seems like a busy.
This really is phenomenal.
I thought it was a coding error. I mean, it basically, there's one here that flips back and forth, so it gets about 92 to 95% accuracy, and that's this one here, this triad model method. As you can see, there's kind of a dark band here, so basically it flips between the orange and blue cluster, depending on how, which exact cases you put in. So I use cross-validation in order to, so I segment the data sets into different subsets to validate the error metric, and occasionally this one will flip. So yeah, there's like one here that kind of sits between these 2, which is interesting. And you can do more clusters as well, right? You could say like, oh, what if it was 4 clusters? How would that change things? And so you can do things like that. But right, yeah. So we're going to do. The idea is to do that with a larger. So this is just 39 methods on the 800 or 9 cases that I had for this data set. But we have a project going on which is looking at a much larger set of methods, trying to uncover structure in those as well. Yeah. Okay, cool. Okay, so that's which methods kind of work together or complement each other. But that's maybe I have the methods I'm comfortable with. But all I want to know is if I go to a new type of problem, is there a particular kind of method that's maybe I don't use regularly, but is really well suited for that particular kind of problem. And the way that you can sort of play this is looking at, again, we have these focus areas for each case, coupled with the methods. You can say, oh, well, for water-type problems or for agriculture-type problems, are there particular methods that statistically come out much higher than in the non-water cases? And that basically is a large-scale hypothesis testing problem. So you can do something like a normal QQ plot where you plot your expected statistics versus your actual statistics, and you end up with this, right? There's this line where basically there's no difference, right? Like one method basically doesn't differ between a water type of problem and a non-water type of problem. But all the stuff that's off this line, that is significantly very different than what you'd expect. And if we take a look, that's exactly what you'd expect, right? Agriculture uses farming interview guides significantly more often. Right? I mean, okay, I could look at that and tell you that's probably an agriculture problem. But the fact of the matter is that the algorithm has no idea what farming even is. It was able to pick up just on the usage that was something that was useful for agriculture. For community development, they use a method called participatory co-design. This is when you take a designer, embed them in a community, and have them design something together with the community so that it better fits what the community's needs are. Right? And it picks that up without even any knowledge of what a community is. Right? You can have community-driven discovery, for example. So this is just a way for you to take what is normally just looking at design methods and view it as a large-scale statistical hypothesis testing problem, and you're able to actually extract out which methods are particularly useful for particular types of problems. Okay. Right. So, okay, we know all this, that's all really nice, but at the end of the day, what I want is, I have a problem, I need you to tell me what methods I should use, right? Either I can look at your graphs, or you could just recommend for me, if I'm going to go to this area, I'm going to do an agriculture problem, and I expect to do some kind of interviewing, is there a particular method that I definitely should do, or like, what's the next thing you'd recommend if I had an extra amount of budget? And so to do that, it can build something called a recommender system. Those are typically
so you're trying to optimize time or number of alternatives.
It could be any. If you want to optimize cost, you can optimize cost. If you want to optimize time, you can optimize time. Yeah, the idea here is just to recommend what's sort of the next method that you should use, and then and that could come with it some kind of tag about cost or time, and you can make that decision. But basically, you want a rank ordered list of the 39, right? So maybe I only have enough resources to do 2 or 3 methods. Give me sort of like a Google search. You type in, I want this type of problem, and it says, okay, here's your ranked list. And basically what we want is to try and make that ranked list as best as possible. That's essentially what Google does. That's how a recommender system works. That's what Netflix does when it recommends movies. It says, oh, Pablo, thanks for logging in again. Here are the 7 movies that we think you're going to want to watch next, for example.
But, in practice, for the design exchange, we're thinking more of relevance.
Yeah.
And
right.
Probably haven't thought of this in terms of how much cost is each one, but which one is relevant subscription.
Yeah, right. Like right now, this thing's I'm just going to talk about relevancy, but there's nothing to stop you from weighting that relevancy with some kind of cost estimate if you wanted to. That's just like an extra little step that you can do. Yeah, so the way that Google and people like them will rate the performance of their algorithms is through something called a precision recall graph. Basically, it's are you getting the results that I want and only the results that I want? Seems like a good metric. Basically, perfect performance would be a line that goes all the way across. It starts at 1 over here and goes all the way over to 1 over there. So you can start to say, okay, well, what if we just recommended methods randomly? I just shake up a bag, I pull out a method, and I recommend it to you. What does that get you? Well, as you'd expect, it gets you pretty terrible performance, not surprisingly. Okay, well, what's the next sort of best thing we could do? Well, why don't I just rank all the methods by popularity, right? So automatically, I'm just going to recommend the most popular methods first, right? Okay, that's better, slightly better results. But obviously, we can do a little bit better than that. We can look at the text of the problem itself, right? So just take a look at the text that they've described, and you can. I use something called a latent semantic analysis, which embeds all of the words that are used into a kind of 50-dimensional space, and then you can train a classifier on that space to classify which methods might be better for which types of problems. That turns out to do slightly better, right? So that's random forest classifier on just the content. But it turns out that the best thing that we were able to accomplish was using something called collaborative filtering. So this is, again, ignoring the text of the problem, just looking at how methods are used together. That matrix that I showed you earlier, that performs uniformly better than any single metric or even something as complicated as a random forest built on text. So there's a lot of information embedded in how these methods are used together that helps improve recommendation, helps improve our understanding of which methods are grouped together, helps improve our understanding of which methods apply to which types of problems. And all of this is just gathered from the community-generated data, right? This is all data that we wouldn't have if it wasn't for these online design communities. Okay. Lastly, I want to talk about evaluating the particular ideas that come out of these communities. So, I'm going to talk about this in the context of creativity. So now we have this online community, we have this design process, and they go and they generate tens of thousands of ideas, right? This is great. This is exactly what we wanted, right? Well, not really, because we still have to evaluate which of those 10,000 ideas we're going to go forward with. And if it's something simple like, well, what's the best one? Maybe we can do some kind of distributed voting where every kind of votes on their top 10 and we aggregate it. But to do something like, give me the sort of most diverse set, that's actually a really difficult problem. Say, for example, I had tens of thousands of ideas, and I just wanted the 5 ideas that best describe sort of the diversity of the ideas. I want a sort of a diverse product portfolio, so give me the 5 that best represent the diversity of the set. Say it's these 5, right? That turns out to be a very difficult problem. It's basically a combinatorial optimization problem. Humans can't do it, computers can't do it. Basically, a human would have to just guess. They'd have to cluster a few things, and there'd be some kind of approximation. It'd be very difficult for one person to go through and actually scan through 10,000 ideas, right? So, question is, how can we use some of the data that's being generated by collections, these crowdsourcing communities, and use them to make this problem a little bit easier? And so to do that required so we need to find a way to essentially optimize or understand creativity in all of these different things. And one of the key ways you could do that is through something called diminishing marginal utility. So that's the more I have of something, the less it's worth, or the less it is worth to me. This is basically at the core of creativity, right? If you give me 5 ideas and they're all mobile phone applications, right? That's not a very diverse set, right? If you have 4 ideas and you say, oh, well, would you like another mobile application on top of that? that doesn't have much additional marginal utility, right? Because I already have for mobile phone applications, maybe what I want now is some kind of physical product, or maybe a different kind of business model, right? That's diminishing marginal utility. And it turns out that there's a mathematical object called a submodular function, which basically perfectly captures that diminishing marginal utility property. So the idea is, okay, if we can take each one of these concepts and figure out how they contribute to some kind of submodular function, then we could essentially optimize over this entire set and pull out the 5 that best approximate the most diverse set. Problem is, how do we figure out what is this function, where does it come from, how do we figure it out? And so the way you can do that is instead of asking one human, hey, go through and look at all 10,000 of these and tell me which 5 are your favorite, you can say, okay, well, why don't you just look at the red set and the blue set? And you just tell me, okay, look at the variety in the red set and the variety in the blue set, say, and which set has more or less. That's a fairly easy thing for a human to do. I'm not asking them to look through 10,000, I'm just asking them to compare 5 ideas to 5 ideas. So I can ask them, can it give me a rating, red versus blue? And then I can go to another person or the same person and say, okay, well, how about this set, red versus blue, right? And so now what I have is a bunch of red versus blue comparisons that are telling me for different sets of ideas, which one has more variety or more creativity or more novelty than another set. This I can turn into a classification problem. This is essentially, I can use a logistic regression model that has these submodular functions underneath it, and instead of having to figure out exactly what that submodular function is, I can use these red versus blue ratings to optimize it for me. And so basically what I end up with is something that can predict which red versus blue rating it is for a new set of concepts. Right? If I showed you 5 new ones, it could tell you what the human is likely to rate. And that's really the point of all this. And so what we did is we compared that with a sort of a benchmark, this sort of benchmark metric that is already being used, and we essentially use that to simulate thousands of these red versus blue comparisons. And then we have a logistic regression model that tries to predict, okay, how well do I match what I should be saying? And so that's what I'm going to show you here. On the x-axis is the number of comparisons, the number of red versus blue comparisons, and this is the accuracy. So if you want accuracy to go to 1, you're going to completely match what you should be saying. And it turns out you only need about 500 or so comparisons, which would take 5 humans about half an hour to do. So you're getting, for that, something that can be repeatedly used across all 10,000 and get you an optimal estimate of what the sort of best 5 variety sets are. Okay, great. So that's just a quick overview of the different areas that my dissertation has worked through. So now I want to talk about a little bit about where do you go from here, right? So this is all well good. What's the next step? Well, a lot of these things that I've talked about right now are primarily built around the analysis of existing data, right? So we have a community, we have a process, we have some ideas. How do we analyze them? And the future really is more towards synthesis. Can we use this data in a productive sense? Can we use it to generate new communities, new processes, generate new ideas? So for example, in communities, you can do work in community formation to say, okay, can we assemble a good design team out of all of this, right? Can you tell me which 5 people I should collaborate with? And so we're working with IDEO on this problem since they want to try and do that for their people. The processes, you can start to think about training and education, right? In the HTTP Connect example, this was about how do you help novice designers go through and look through these cases. But you could also flip that on its head and say, hey, you haven't practiced this particular kind of skill, or you're not familiar with this class of methods. Is there something that we could recommend for you to try, or a problem that we could give you that could help train you on this? You could also think about design interfaces for creating ideas. So can we leverage all of the information that people are doing, all of the actions people are doing in order to make better interfaces that help people design things easier or faster? They can open up design to a wider group of people. Okay. So just in summary, I've talked about the 3 trends that are kind of pushing my research forward, how I structure it, which is about communities, processes, and ideas, and what we get out of it at the end if we're successful, which is that we end up with this sort of 3rd pillar of how you can do engineering, which are these online design tools. Okay. All right, so I just want to close with a quote by Herbert Simon, who in his article, The Science of Design. He's an economist, computer scientist, philosopher, polymath, won the Turing Award. Anyways, this is a quote from him. It says, the proper study of mankind has been said to be man. But I've argued that man, at least the intellective component of man, may be relatively simple. then most of the complexity of his behavior may be drawn from man's environment, such as these online design communities, from a man's search for good design. But I've made my case that we can conclude that in large part, the proper study of mankind is the science of design, not only as a professional component of a technical education, but as a core discipline for every liberally educated person. Right? So what he's sort of driving at here is not only that there's sort of two things the way that I read it. One is that everyone's a designer, right? That we all do design. That's what you see in these online design communities as well. People are wanting to get together to design new things. But more in that the study of that process, of this environment in which we're situated, by using some of these tools that I've mentioned, things like spectral clustering, things like recommender systems, it's not only just a way to make these design communities better, there's also a way to understand our own behavior and basically understand our own humanity. Okay. So thank you guys for your time. I also want to thank everyone that's helped me over the past 4 years that I've been at Berkeley, including the Berkeley Institute of Design. And thanks for all you for coming as well. Any questions? Awesome.
Part that's not clear in my head is the element of somehow experience. You have been doing agricultural design for like 20 years. The probability of selecting the right methods for that specific problem should be in theory higher than just a random group of people or designers, let's call it that. So how do you, do you account for that in any way? Is there like any way that you can add to your algorithms? Is there like any, or does it matter actually? I mean, it seems like what you're proposing is the power of the crowd is sufficiently strong that you don't need super experienced people. So you just need critical mass.
Yeah, that's an interesting question in terms of what's the role of experience basically in these crowds, right? If I have one person who's super experienced versus 100 people who aren't super experienced, how do you trade that?
I guess just to complete my, I'm thinking in the heuristic evaluation sense, like Nielsen, right? He says like, with 5 people you can get pretty much 70% of issues out front, right, when you're designing. Right. And then you can concentrate on the rest. So in this case, what you're saying is like, we don't even need that. We just need lots of people and just put them to work.
Yeah, I want to be careful there. I don't want to necessarily say that. I always hedge my bets by saying I don't think that these online design communities will ever eclipse something like GE, right? I mean, there's always going to be a place for each of those 3 ones that I talked about. And that there's a certain technical expertise that comes with really knowing a problem that is not easy to translate just to a massive amount of online people, right? So I wouldn't want to necessarily be in a jet engine designed by a crowd of people, but like if it's my air conditioner, maybe that's not a big problem. So I think there's some technical expertise that you can play there. I think at the beginning you mentioned something about how can you kind of weight it, like if you have some experts versus some non-experts. And there are certainly algorithmic ways to do it, but I think sort of fundamentally, philosophically, there's no reason why you can't have a mixture of both. And indeed, in a lot of the crowdsourcing work that's been done, not necessarily for design, but for things like image labeling, they'll have explicit models that will encode the ability of an individual, and those models will try and learn that ability over time. So, if I show Vivek and Pablo, several things, and Vivek keeps getting it wrong and Pablo keeps getting it right, then maybe at the end of the day I weight Pablo slightly higher in his ability to accomplish this task. And they'll actually formally encode that in some kind of statistical model. So there are techniques like that as well. I don't know if that answers the question.
There's a big difference between is the expert on good design, there is the expert on understanding consumers. What Ulrich was looking at is consumers are probably better experts than the experts of what consumers want. In other words, a small sample of relevant consumers will probably do a better job than the CEO of GM or people that are in positions to spend a lot of time evaluating design, as opposed to people who actually experience the design or are looking at a new area or something else. So as soon as we get into kind of what we're talking about, experts.
Yeah, I mean, if you already have the product, like the air conditioning, we've been using air conditioning for what, like 50 years, 6 years, something like that. So I can see that, consumers have somehow good understanding. Now, do we know how wearable should look like?
That's a whole other.
It's a whole new question.
And so if it's a variation of something that they have some
Right.
something that they have some experience with, I mean,
Yeah.
But your approach, at least on the submodularity, could be, you could actually get real, if you have experiences for people to rate, you could do that too.
Right.
If you want to know if they're radically.
I think there's a mixture as well. Like, it doesn't have to be one or the other. For example, Quirky is a great example, like the Garth and Leslie example. So the crowd didn't do all of the. So Quirky, what they are is they're basically a design for manufacturing house. So like once somebody comes in with basically a fully formed idea, they'll go out to their injection molding suppliers in China and their stamping suppliers, and they'll worry about draft angles and tolerances and all this because that's what they're experts in. Right? They don't have necessarily the bandwidth or time to go out and do all of the consumer research to figure out what kind of air conditioning is like. They had a part of it was they had the crowd go out and send in photographs of their windowsills so they could get a sense of like how are people actually going to use all of these, and so they'd get all sorts of interesting fixtures and things they weren't expecting, and that would have been very difficult for them to go out and do themselves if it was just one person in their company who was responsible for that. So they used the crowd basically just for the front-end portion, and then they said, okay, well, at this point, the design's fully formed enough that we don't need them anymore because we're the guys who are experts in tolerancing and design for manufacturing. We'll take it from here. They took it from there, and then GE kind of stepped in with their machinery and said, well, we're the experts in advertising products and pushing it to market and getting out to all of the retailers. And so they didn't rely on the crowd for that part of it either. GE took it and then said, okay, we're going to do this part of it now. And so I think that there's some balance that will happen there. DARPA's example, they basically spent all of their time investing in this set of tools. They had a set of tools that you could use, and those tools were designed such that a lot of the difficult sort of gnarly engineering decisions would be correct by construction. And if I put like two pieces together, it would automatically make sure that they made it correctly because that's the way they had designed their software for a very particular application. And so there's kind of built-in safeguards so that the crowd sort of couldn't mess it up. And so there's different ways you can approach it, right? Quirky is more of a business model perspective. DARPA's strategy was more of a let's build a tool perspective. Yeah. Does that kind of address your question?
Yeah, in one sense, I guess the one component of experience. When I said experience, I think it wasn't clear enough. For example, is this element of emotion or like fun and coolness and just adaptability of something. If people like. I've been doing research for mental health, and we have been coming with algorithms to get people to actually do things that calm you down. And some people find value in it, but then eventually they get bored. Even though the thing works for you, they get bored. They want something new, like novelty. How do you embed novelty? Because even if it's even if the functionality is right, the emotional component might still play a role. And that part is very hard to judge. Like I've been like working with designers, and they come with these like very unique ways of looking at like this looks cool. It's like, why is that cool? Why is not this other thing cool? Well, because this is what's trendy and this is what people like. That's so hard to embed. Like I mean, the functionality part. Back to your last comment, the intellectual part is interesting, but the emotional part is very hard to quantify. I mean, I think that component. I don't know. It would be great to see if we can actually add elements of emotion.
Yeah,
I guess we can.
I mean, at some point you run up to the barrier of like there are things that people just don't agree on enough to even. I mean, if you, in some sense, if you take sort of garbage in, you get garbage out, right? Like if there's something that no one can agree upon, then there's no use trying to learn what that thing is if no one can agree upon in the first place. So I mean, that's always going to be a difficulty. Is like what's the sort of inherent error or noise in the signal that you're trying to capture. So that could be the case, but at the same time, you can work towards like some of the like Alice mentioned the submodularity piece with the novelty. I mean, there is a mathematical way that you can think about novelty, and will it be accurate? for all the time for every case? Well, no, not really. But that's not what engineering is about, right? Engineering is about finding something that gets you a reasonable approximation with a minimum of effort. And so that's something that could work actually fairly well, right? In terms of novelty, you brought up for that. If there was a way for you to encode what are sort of the features of each product, then there is a way to mathematically understand novelty in terms of diminishing marginal utility and make some progress. And it wouldn't solve everything, but it would be like one way to start looking forward.
I think that variety fits better, whereas novelty depends on reference.
Yeah.
Reference to something. Is it not a reference to your own experience? It's a reference to what you see.
Yeah.
So I think that's
Yeah.
my question, we were talking about whether you need to do human experiments in finishing your dissertation.
Yeah.
That might be worth discussing what would be involved in it.
Sure. Yeah. So she's referring to specifically this one here, where I was talking about you show people bunch of reds and a bunch of blues, and you ask them to rate it. So currently, the way I did this for the original paper that we submitted is there was an existing variety metric, which was basically when people want to evaluate creativity, they do one of two things. Either they just farm it out to humans and say, just give me some numbers, just like 1 out of 10, what do you think? And they just ask lots of people to give them lots of feedback, which doesn't really scale to tens of thousands of people, so that's sort of a non-starter. The second way is you'll basically write a formula. They say if you have this many, if you used water to propel it, you get 1 point. If it was a wind to propel it, you get another point. And so they'll basically come up with a formula that gives you a bunch of weighted points to do it, which is not really satisfactory because it doesn't. Basically, you invest all this time to make this one formula, and then that's very restricted in terms of domain. So this was an attempt to say, okay, well, can we use some human data and then some mathematical representation and come up with something that can learn that representation automatically? That was essentially what I was doing here. And so this graph here was one of those formulas, and it was basically using those formulas, not looking at the formula, but just looking at the feedback, the A, B, the red versus blue out of it, and trying to estimate or predict what the formula would do. So that's again just. No, because I just simulated it based on it was a simulation study, right? So the question Alice is asking, or the thing that I'm trying to wrestle with right now, is do I go ahead for my dissertation and also now go back and say, okay, well maybe I take all of the winning concepts from OpenIDEO challenges for the past 20 challenges, that become these dots. And then I go through and I pick randomly 5 of them, and I do exactly what I just described, except instead of judging using that for a mathematical formula, now it's accuracy with respect to how well can I pick up. Say if I'm judging this mobile application for maternal health care versus this business model for delivering maternal health care, and I try to predict, okay, well, which one of these sets of designs has more variety? Can I correctly predict what Vivek says is one or the other, rather than this formula?
So the question that I'm curious from this group, since you each have your own data sets, what are you thinking other than OpenIDEO data set, or does someone here have a data set that might be interesting to discuss?
Well, I'll tell you, I was either thinking OpenIDEO's data, since it sort of aligns with the rest of the dissertation, or the NPD data that we have, NPD concepts. From Alice's new product development course, we've collected hundreds, thousands of different student solutions to different problems over the years, so that's a possible data set as well.
We might just look at Next Digital.
Sure, that would, Next Digital would be fine, if they have enough concepts for it to be.
Also,
yeah, if you have more than, let's say, 50 designs, then that's a possibility, yeah.
This semester I required student.
Oh, that would work. So that's
well,
possible.
we're going to be designing interventions for stress. Initially, what we're doing is our approach is to harvest the interventions from the web rather than getting psychologists to do it. Like we want to get rid of that. We want to just harvest info from the web, and we're going to get crowds to start creating their own information. So we're going to get hopefully hundreds or thousands of things that if you're interested, we will talk about this.
Okay.
The app's not ready, but by the end of the summer we should have it.
Maybe in his new job, you could do it.
Yes, it's true. Yeah. Yeah.
I think you should extend online institution course and look at all the designs that the kids are creating at the
That's what I'm saying.
They have monthly long design meetings,
Uh-huh.
challenges, and the people that can like create a variety. I've always really wanted to stay with it.
Cool. Okay. That'd be
So
cool.
we should also do that in your next job.
Sounds good. Yeah, I mean, the reason I was going to pick Open IDEO was just because I have the data and it's something I could do in the 3 weeks that I have to finish everything.
Time constraint.
So who would you get?
I don't know, I mean, remember what we did for the other variety work, where I sent you that web link and then we just emailed it out to a bunch of people? I could build something similar for this.
Why not Turkey?
I thought about Turkit. It's possible. I could do that as well.
The question is, do we want design experts or do we want?
That's the central question, actually. Right?
Well,
Yeah.
I mean, it'd be interesting to
Compare.
Of course, 3 weeks. There's not so much time.
Right.
But I mean, if you need it, just put it on Turk.
Yeah.
The same file that you would have done for X.
Right. Actually, I gave a similar talk at GE Research a couple months ago, and they asked a similar question, and they were like, oh, well, maybe not Turk. So we got into a big discussion, and they're like, oh, well, mechanical Turk probably not, because you don't really have any control over their expertise. But something like Odesk, right? Odesk is one where people have to put their occupation and they have a certain experience level, so you could filter by just designers, right? And just give that to designers. Yeah, there's also something interesting about just comparing it, right? Like you get a bunch of Turkers, and then get a bunch of Odesk folk, and then get a bunch of random people that that are maybe design graduate students, and then a bunch of professionals, and then compare. Yeah.
That would be cool.
Yeah.
Sure, that is good.
Yeah. I mean, one of the cool things about one of the graphs so this is all with respect to ground truth, but you could also show it with respect to agreement among the raters. So you can look at just like how well does each rater even compare to one another, and that can be under the high noise condition, right? You're talking like inter-rater agreement that's like fairly terrible. Like even the raters can't agree on what the best thing is. But because this thing assumes that they're all centered around a single point, this thing actually gets a more accurate prediction than any single one of the experts themselves. Because the experts themselves there's so much variance that this thing that assumes that everyone has like a common reference that's like, this is what is created. I remember in my qualifying exam, I showed this, we were talking about this as well, and we talked about, okay, well, could different people, like, if I showed a bunch of designs to architects and then a bunch of designs to engineers, could they just have systematically different views? Maybe each of them is the same, or has a similar idea, but between the two groups, they're very different. And so if you segment them that way, you might get really clean data, but if you just dump them all together, you'd see this crazy bimodal distribution where all the architects think that this building concept is awesome, and all the engineers think that this product is awesome, and not the other way around. I anticipate that could happen as well. I think the more heterogeneous your community is, then the more implicit error you're going to see in there.
Well, you brought up topography. There are people. It's self-fulfilling prophecy.
Mm-hmm.
When they have their own design rules and violate them, stop God or something. So what you get from an expert designer would be much different than what you would get from a general person. It doesn't mean it's any more or less novel.
Right.
It's self-fulfilling. And what we found with the formation, that when we had architects and experts in architecture rate the open source ideas that we outsourced ideas we had, they were consistent. So the self-evaluation of the architects and designers pretty much have very similar ratings as do the expert architects and designers. But then when we have the customer, this combination, there was no correlation, it was small numbers. But it didn't, look at all close. And the reason was it was novelty. Novelty was very important to the architects. And this is why I like variety things better. Because one of the winning designs, the ones that the customer really liked, looked too similar to the California Museum of Science. And it was a great idea that the Nobel Foundation really liked it, but it looked like too similar to another design. And that the Pomo just cared about a great design, right? Whereas the critical acclaim from the professionals wanted something that was novel.
The other thing, though, at least to consider, is that novelty, as you said, is subjective and it's dynamic. It changes over time.
Yeah, it's I mean, all of these are subjective.
Yeah.
But I think with novelty, it changes because of that. Whereas I think writing has.
Yeah. They talk about whether something is historically creative or psychologically creative. In other words, is something novel with respect to all previous ideas that ever existed by anybody, or is something psychologically consistent? Yeah, I tell the story like if you have a 7-year-old who's never been in this culture without an iPhone, then the first original iPhone would look pretty terrible because it will just look like a crappier version of modern technology. But to the person who was around when the first iPhone came out, that was like huge. And everything else that's come out from that has been just a minor increment on a really novel technology. So, yeah.
Have you seen those videos of kids using old technology?
Oh yeah, I saw.
Yeah.
I mean, you could do the opposite. So they're so used to the iPhone. So they would videotape these kids using an old cassette player. And that would.
There's an even better one with an old.
Oh,
And they're
telephone, rotary
they
telephone.
turn on the monitor and turn it on. You turn on the power button.
But to them, this is novel, right? A rotary telephone was novel.
But see, that's what I'm saying. That things come back from the past. That's simpler sometimes. You want, retro.
You know about it.
Yeah.
Not retro. I've never seen it.
Yeah.
So I had a question about something you mentioned in the last slide, like the future direction problem, incorporating this type of analysis into a creative tool. And it seems like a lot of this analysis is very discrete. What is the most creative design in this set of designs?
Yeah.
And for me, I feel like design is much more of a practice, right? Increment. As you go through it, you become an expert by the amount of time you go through that process, not necessarily the method.
Right.
So I wonder how you see this type of analysis being used in design tools, where like you don't necessarily have the final design. You have a person going through that design. How do you aid them with that type of data? So I guess I'm asking, for instance, for network data, it's like I get the feedback that I have 2 collaborators and I'm on the fringe.
Yeah.
And I want to get toward the center.
Right.
Is that type of analysis saying that I should get more collaborators? And how do I get that feedback? Like, just how do you imagine your analysis?
Sure. Like one of the projects we were working on with OpenIDEO actually like 2 or 3 months ago was on dynamically, so like when a challenge starts, you can start to see these connections form, right? And you have all the historical data about what people have done. And so now you can say, for instance, they went and they did their own segmentation, like they interviewed about 200 people, and they basically classified people into 3 different groups. And they found out that person from group A would always do an awesome job if they had somebody from group B and C. And person from group A would do or wouldn't do anything if they didn't have person from group B and C. And so what they want to know is, can we identify automatically by looking at that, the graph that I show, like, can we figure out who the A, B, and C people are? And then as the challenge starts, maybe you can be explicit by saying, hey, can you comment on Rachel's idea? Or you can just say, hey, welcome back. Here are some 5 ideas for you to comment on, and then change that ranking, underneath. Yeah. So I mean, that's what I was talking about before with the synthesis part of it, where you talk about how can you do dynamic community formation. That would be an example.
So you have a lot of
Yeah, right. In Open Ideas case, that would be certainly the case. And in the HCD Connect case, the one with the matrix and the 3 clusters, actually those 3 clusters turned out to be time dependent. So like the one cluster was the thing you do first, the second cluster was like the second stage, and so there you can kind of say, oh well, you just started, you should start over here. You want to do this thing? Oh well, you shouldn't do one. You should do one from here. Now you're done. Let's move on to the next stage. So you can start to sort of structure that as well. Yeah. Yeah.
I was just interested in the idea of evaluation, like evaluating creativity versus evaluating just how good the idea is, like how useful it would be, and how you can evaluate that. I mean, some of these examples that you presented, like, were they just all the ideas submitted, and then the VPs pick the ones that they like, or like, how are they actually coming to the final design? Do people actually prefer going to design?
Yeah, so I'll tell you how OpenIDEO does it. So there, you submit an idea, then it goes through a phase of about 2 or 3 weeks of community feedback. So Edwin would log in and he would look for a design. Oh, that's really cool. Hey, have you thought about applying the, you mentioned a mobile phone app, like, hey, what about this thing in Kenya that they do with the mobile payment? Could you use that? And so they'll leave comments and stuff in the thing. And then people have a chance to revise their submissions. So they'll go through, and this is all community driven. Then at some point they switch over to an evaluation stage, where now everyone just goes on and they have a list of maybe 5 or 6 questions, like, how likely is this to be implemented by the government of blah, 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 whatever. And they'll have people go in and say, like, oh, 5 out of 5, or 1 out of 5. And that's all community driven. But those questions are selected by the sponsors or by the people who are running OpenIDEO. At the end of that, they'll look at the evaluations. They'll look at like applause, which is their Facebook like versus not like metric, yeah. And then at the end of that, then they'll select 20 ideas that are like their finalists. Then the board of the IDEO people get together along with the sponsors, look through the 20, and then they try and optimize jointly for how likely is it to actually work. Is it good? Trying diversity, like they'll actually specifically try and do variety, like select of the 20 ideas, what are the 9 most diverse, for instance. So they have a bunch of them. Yeah, and they just do that manually. Yeah. Yeah, combination. And then different companies do differently. Like Quirky does it differently than OpenIDEO, which does it differently than DARPA. Everyone's still figuring it out. I don't think there's like one right answer.
In the idea submission stage, is it all just continuous? So people are submitting ideas when it comes to them.
Yeah.
But then there are also competition style things, which some kind of, like with the DARPA, you said they pose,
right.
challenge.
Yes, that one there wasn't. So DARPA's challenge was a lot more closed in that sense than OpenIDEO. OpenIDEO, as soon as you submit it, if anyone can view it, anyone can comment on it, anyone can steal your idea and repost it with a slight modification. They do have what's interesting, and it's a project I didn't talk about, was they have basically a citation graph. You know, like in research papers, if you see a cool idea in a research paper and you build on it, you cite it, they have the same thing in OpenIDEO. So if say Cesar makes an awesome mobile app, and I say, oh, well, I'm going to make a sensor that you can plug into your thing, you can use it, and then I can say, oh, yeah, I have this idea, but it built off of Cesar's idea. And so I took it out for this presentation, but I can actually show like the temporal citation graph of all of it. And one of the projects we're working on is how can you predict when Edwin posts a thing, what other ones might be useful to him. Like, hey, you just posted about a mobile application. You probably didn't have a chance to check through all 5,000 ideas. Here's the like 10 that look like they're really closely related to your idea, and that's how then maybe it also gets back to your question, which is how can you use this more generatively? Yeah, so I'm actually currently working on a project for that. Yeah. All right, well, I don't want to keep people anymore. I'm going to stick around for questions, but I want to let everyone go because it's 4 and 9, so I don't know if you need to go anywhere.
And quick announcement.
Oh, quick announcement.
I was just told me to do it, but I just sent out an email, but I'm going to be doing a practice talk Wednesday, so 2 days at 1 p.m. here also. And it's for a conference next week
engineering education.
Cool. And Jen's
So
stuff.
I would appreciate if you guys can come.
And Jen's stuff is awesome.
7 minutes worth of talk?
Huh?
Okay.